Yeah, welcome to VLSI Simplified YouTube channel. As a part of this Verilog 30 days lecture series, we completed with day 13. So we are in day 11. So in day 11, I will show you how to, so we are dealing with the mod encounter. So I'll show you how to execute this code in EDA Playground and Vivado, okay, AMD Vivado and Quartus Prime synthesis in quarters prime and simulation in model sim. Okay. First I will open this code. First I will explain this code and after that I will execute. So here if you see, uh, so module, what is my module name? Module in underscore counter. So here I'm using parameter concept. Okay. So parameter means what? Parameter constant. That is I'm giving the n. So mod of this value, mod of the counter is 15 and the parameter width is how much? 4. Okay. So what is the importance of this parameter means dynamically I can change the parameter values, parameter constants. Okay. And dynamically I can change. Suppose if I want like so here I designing mod 15 counter, no? Suppose if I want to design like more counters like mod 30 counter or like that, so dynamically we can change. Okay, so that's why here like this I am declaring as parameter n equal to 15 and width parameter the width equal to 4. Okay, and I'm declaring input reset n. Okay, output reg width minus 1 is to 0 out. Okay, so that is what is the width 4. Okay, 3 down to 0. So width is output out is a 4 bit and I'm declaring with reg data type. Why? Because this out I'm declaring in the procedural block. Okay, this is a behavioral modeling style. In the behavioral modeling style, I need to write whatever the logic in the always block. Okay, so this out I am going to use in the always block. That's why I need to declare with reg data type. Okay, and always at the rate passage of clock. Okay, this is synchronous reset. Okay, begin active low reset. Okay, synchronous active low reset. So if not of reset, if reset equal to 0, out I am initializing to what? 0. Okay, else if out equal to n minus 1 also. So n minus means 1 means what? Suppose if it is a counter. So if it is a mod n counter, it will start from where 0 to n minus 1. After n minus 1, it will come to the initial state. Okay. So if it is a mod 15 counter, it should count from where to where 0 to 14. And after that, after 15 comes, it will come to the initial state. Okay. So here it is checking whether out is equal to n minus 1 or not. When it out is equal to n minus 1, then out becomes what? 0. Otherwise, you are incrementing out. Out is a non-blocking with out plus 1 and n module. Okay. So this is the basic RTL code. Okay. And coming to the test bench. So for the sequential circuit, as I told you, test bench have 5 steps. So here module, this is my module name, TB modern underscore counter. Parameter, I am declaring parameter n equal to 15, parameter width equal to 4. And so here test bench doesn't have the inputs and output, it have the variables. Okay. So I'm declaring with this reg clock and reset and out with where width minus 1 is to 0. So width is 4. So that is 3 down to 0. Okay, 4 bits are there. So I'm declaring with a vector. Okay. So when you are declaring the size before the variable, that will become the vector. Okay. And next I need to instantiate my design. How to instantiate my design? So here, what is my design name? This design name should match. Okay. Module n underscore counter. Okay. So module n underscore counter. So like this we need to use. Okay. When you are using parameter. Okay. Ash dot n dot width dut dot clock dot reset n dot out. Okay. So whatever the variables outside the bracket are design inputs and outputs, and variables inside the bracket are test bench variables. Okay. So this is actually instantiation connection by name. Okay. And next you need to generate the clock. Okay, with the 20 nanosecond period. So always I given the time scale, no? Time scale equal to 1 nanoseconds by 1 picosecond. So when I'm giving the delay, here delay I'm giving as 10 means it will take as 10 nanoseconds. Okay. So picoseconds is actually precision. Okay. Depending on the decimal value, it will round off or it will be truncated. Okay. So here I am declaring like the clock will be off for 10 nanoseconds and on for 10 nanoseconds. So always hash 10 clock equal to not off clock. So that I'm generating a clock with 20 nanoseconds period. Okay. Initial begin. Okay. So these are the steps. First you need to declare the internal variables. Next you need to instantiate your design. And next you need to generate the clock. And next you need to initialize the reg variables. What are the reg variables here? Clock and reset underscore n, no? Reset n is there, no? So those we need to initialize. Okay, initialize the signals. And to execute in EDA playground, we need to set up the dump files. Okay, so what are these dump file? Design name dot vcd, modern underscore counter dot vcd, dump vars 0 comma tb underscore modern underscore. This is test bench file. Okay, this is actually this is my output file. This is dump all the signals into test bench. Okay, and next dollar monitor. So t equal to percentage 0t and reset equal to percentage 0b and out equal to percentage 0d. So these are actually format specifiers. Okay. So like time means what it is displaying in terms of time. B means it is displaying in terms of binary. D means it is displaying in terms of decimal. Okay. So dollar time, reset in and out. Okay. So whatever the change in these variables, dollar monitor is a system task. Okay. So whatever the change in these variables, it will display. Okay. So that is dollar monitor. And I need to check for this counting sequence. No. So for this, what I'm giving means I need to hold the reset signal for 2 cycles. Okay. For this, what I am doing, repeat to at the rate passage of clock. Reset is non-blocking with 1. Okay. So again, I want to run for 20 cycles means repeat 20 at the rate passage of clock, dollar finish, end module. Okay. So this is my test bench. Okay. So here I want to execute in EDA playground. First I'm opening the EDA playground. So this is my EDA playground. So log in with your mail ID. Now my code is there, no? This code, select all, copy, and in EDA playground, here design, paste, go to test bench, select all, copy, and here in the test bench we need to paste. Okay. Go to tools and simulators, select Aldec Rivera, and open EP waveform after run. Okay. So run this code. So I will get this output. See here. First, I want to see the reset. Okay. When reset equal to 0, so output will be 0 only. So the count will start here from here. Okay. So G1, 2, 3. Okay. Here 3, 4, 100, 5, 101, 6, 110, 7, 111, and 8, 1 triple 0, 9, 1001, 10, 1010, 11, 1011, 12, 1100, 13, 1101, 14, 1110. Okay. After 14, again it is starting from the initial state. Okay. So like this, it is counting, up counting. Okay. It is acting as a up counter. Okay. So mod 15 up counter. Okay. So like this, we can see in the simulation part. Next, coming to the Vivado. So go to project, new project. Next, let us give the project name as what? counter, counter, hmm? Counter underscore param, parameter I'm using, no? Param. So, so where I want to store training and development and training and development, VLSI material, VLSI design material, 30 days, and we are in 14th day. Okay. So, yeah, I want to select this path. Next, this is my RTL project. Next, I want to add the file. Okay, so give the module name only. So what is my module name? Module name is the file name, mod encounter. Okay, copy this and here you paste. Choose the location. Okay, so here I created a counter param. No? Select OK, next, and next, next, finish. I'm giving same as module name only. So go to mod this one counter. So go to this design, select all, copy, and here you paste, save, okay, and go to the simulation, add the simulation sources, create the simulation sources. Here, this is my test bench file name. Copy this and paste. Choose the project location counter param, select OK, finish. And I want to give the same file name as same as module name. So go to the simulation and here right click, select all, copy and paste here, save. Yeah. So my design is instantiated in the test bench. Okay. So I want to see how the tool is converting my code into gate level netlist. For this, what I need to do, go to RTL analysis, open elaborated design. Yeah, it is elaborating the design. Yeah, like this. In terms of mux and d flip-flop, so total how many flip-flops are there? As mod 15 counter means four flip-flops I am using. Okay, four flip-flops, and this is the mux, and this is plus. Plus means what? Counter. Okay, so the output of Q is given to the adder circuit. Okay, like this, reset and clock is there. Okay, so like this, whatever I wrote the code, this tool is converting my code into netlist, gate level netlist. Okay. For the simulation, run behavioral simulation. So I think dollar monitor I gave no. So you can see in the TCL console also. So when reset equal to 0, out equal to 0 only. When reset equal to 1, so it will count. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, up to 14. 14 it will count. Again it will come to the initial state, that is 0, 1, 2, 4, 2, 3, 4, like this you will get. Okay. And you can see in the simulation window also, see here. So you can get, so that means when reset equal to 0, so this will be 0 only. Okay. And when reset equal to 1, you are getting in terms of hexadecimal. Suppose if you want in binary, go to right click here, out 3 down to 0 is there, no? Right click radix, I want to see in binary. So you can see in the binary. Okay. 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. Okay. Like that. Last value will get triple 1, 0. That is 14. Okay. So during passage of clock only the count will change. Okay. Why? Because always block we wrote no, always at the rate passage of clock. Okay. And next after this again it will continue. Okay. So like this we can see the simulation part in the AMD Vivado, AMD Xilinx Vivado. Okay. Next coming to the quarters prime. I'm opening the quarters prime. Go to new project wizard. Next I want to choose the file where I want to store this file. Okay. So here 30 days in day 14, I created three folders. One is RTL, SIM and TB. So whatever the RTL related files are there that I need to store in RTL, and test bench related files I need to store in test bench, and project I need to store in SIM folder. Okay. Simulation. SIM is actually simulation. Okay. Select this folder and give the project name. Okay. So project name, if you see in RTL, so this is my RTL file. Okay. So in the quarters prime, we are seeing the synthesis part. So we are uploading the RTL file only. Okay. Not TB file. So mod n underscore counter, copy and go to this quarters prime. Give the project name and module name. Next, next, and upload that RTL file. 30 days, 14, day 14 RTL, so mod encounter. Okay. So I uploaded the RTL file. Okay. This is my file name, modern underscore counter dot v. Okay. Next, select any FPGA family board. Next, next, and finish. Now you see. So this has been added in the instance. Okay. So in the go to analysis and synthesis, right click, start. Yeah, I got zero errors. Okay. So after this, go to this analysis and synthesis, netlist viewer, RTL viewer, open. I got this circuit. Okay. So in terms of D flip-flop, muxes, and added circuits. Okay. So like this in the quarters prime, I can see in the netlist viewer. Okay. Netlist, how the tool is converting my RTL file into gate level netlist. Okay. And next coming to the model sim. So in the model sim, I can see the simulation only. Okay. So go to new project. I want to close this project. Give the project name. Okay. So I'm giving the module name only. Copy this and in the model sim, paste. Choose the location. So we are in day 14, no? So go to day 14 and select the sim folder. Okay. So here I want to store my project. Add the existing files. What are the existing files? RTL, mod encounter. Okay. Okay. Again, add the existing file. I want to add the TB file also. TB file, modern underscore TB. Okay. And close. Okay. So select these two, right click, compile selected. Compile selected. and go to the library, work. So this TB file is there, no? Right click and simulate. Okay, simulation starts. So go to this test bench, right click, add wave, DUT, add wave. Okay. So here test bench and DUT files are added. So here this is my test bench file. Right click, group and TB. Okay. And also DUT also. So select these three, right click, group. These are my DUT files. Okay. And go to run all. I want to, so are you sure to finish means no. Okay. So I can get in the transcript window. See here. When reset equal to 0, so out will be 0 XX only. Okay. So here when reset equal to 0, 0, and when reset equal to 1, it will start counting. So 0 to 9, A, B, C, D, E. E means actually in hexadecimal 14. After 14, it will start from 0 like this. Okay. And you can see in the waveform also. Just expand this, zoom full. Here you see. So it will start from where? So here 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, you got 14. Okay, here you got 14. After 14, so what is the counting range from 0 to 14? After 14, it will come to the initial state. So what is the initial state? 0. Okay. So like this, we can get the counting sequence. Okay. So this is all about the day 14. So I designed the counter, mod 15 counter using parameter concept. Okay. Here I used the parameter constant and I declared the mod of the counter and width of the counter. Okay. So like this, we need to see in the EDA playground and Vivado, Quartus Prime and Model Sim. Okay. So in Quartus Prime, we can see the RTL design. That means netlist only. But in Model Sim, we can see the simulation. Okay. Whereas in Xilinx Vivado, we can see both. We can see the netlist as well as simulation part. Okay. So this is about the 14th lecture. Thank you.